Hey, Miss Marion here. Let's go ahead and turn to page 136. We're going to look at lesson 9, I can statements. I can explain why it is true that if the side lengths of a triangle satisfying the equation a squared plus b squared equals c squared, then it must be a right triangle. And if I know the side lengths of a triangle, I can determine if it's a right triangle or not. We are also going to go ahead and look at lesson 10. And that is on page 137, so you have to turn your page. Oh, sorry, I have the wrong I can statements on here. The I can statement is I can use the Pythagorean theorem to solve problems. So go ahead and give your sentence on both of those and a number. So 1, I don't remember, 2, I kind of remember, 3, I do remember, and 4, I can teach it to my friend. We are actually going to go ahead and kind of skip some stuff in lesson 9 because we've already kind of done it, but we're going to look at page 81. And so just as a reminder, using the Pythagorean theorem, we have number 1 is we have these two equations, okay? And then we want to go ahead and we want to use the Pythagorean theorem to go ahead and find both a for number 1. So we're looking both for a, and then we're also looking for x, okay? So go ahead and pause, try that, pause, do it, and then come back to me. Alrighty, so if we look at this, the 7 is actually going to be C. And it doesn't really have that labeled, but we're going to go ahead and do that. So we're going to say that this is C. So we're going to have it as a squared plus 2 squared equals our 7 squared. 2 squared is 4. 7 squared is 49. Then we're going to want to go ahead and get a by himself. So we're going to subtract off 4 from both sides. So then what is left over? We have a squared equals 45. And then how do we go ahead and get a by himself? We're going to square root, because opposite of a square is square root. So we have a equals the square root of 45. And then if we round it to the nearest tenths, square root 45, it is going to be 6.7. All right, so let's go ahead and let's figure out the one with the two x's. So across from the 90 degree is always our C, and so our C is going to be 4. So we're going to have it as, so a squared, b squared, c squared. A squared, so a is x squared, b is x squared, and then we have 4 squared. How many x squares do we have? We have 2 of them, and then 4 squared is 16. To go ahead and get x by himself, we're going to divide by 2 on both sides. So we have x squared equals 8. And then again, to go ahead and get x by himself, we're going to square root both sides. So then x is going to equal the square root of 8. And then if we want to go ahead and round it to the nearest tenths, x is going to equal 2.8. So a little bit different, but we can still work with it, right? And it's totally fine. Let's look at number 2. The triangle here, we don't know if it is a right triangle. We want to figure out if it is. So let's go ahead and stick it in. So remember, there's a couple of things. The C is always across from the 90 degrees, and then the C is always the longest side. So we're going to have a squared, b squared, c squared. C is the longest side, so we're going to have it as 7. Then we have 4 squared, and then we have 6 squared. 4 squared is 16. 6 squared is 36. And then 7 squared is 49. Again, we're going to ask if both sides are going to be equal. So 16 plus 36 equals 52. So does 52 equal 49? No. Is it a right triangle? No, it is not. So again, across from the 90 degrees is always our C. And then the other 2 legs is what they're called, are A and B. Does not matter which one is A, and it does not matter which one is B. All right, let's go ahead and turn to page 87. And so which estimate is closest to the actual value of the expression? Explain your reasoning. So go ahead and work through this, and then come back to me. All right, so for number 1, 24 is going to be closer to 5. If we think about it, the square root of 25 is 5, And so that's actually going to be really, really close up to that 5 itself. Number 2, so the square root of 7. Square root of 7, it is between 4 and 9 as far as the square roots, right? So it's going to be around more 2.5 because it is between the square root of 4, which is 2, and the square root of 9, which is 3. So it's going to be more 2.5. What about 42? 42 is in between 36. So all of these are coming from the squares list. Like 6 squared is 36. 7 squared is 49. And 42 is pretty much in the middle. So this one's going to be 6.5. Now let's go ahead and talk about these ones individual. Square root of 9. Square root of 9 is going to go ahead, or sorry, square root of 10. All right, so number 4. 10 is going to go ahead and be in between 4 and 9. And so 4 squared, so 2 squared is 4, 3 squared is 9. So this is actually going to go ahead and be more closer to 3. And then 97 is 81 and 100. That was 9 squared and 10 squared. So this is 10. If you add them together, it's going to be closer to 13. All right, let's look at page 88 and 89. So Maya and Tyler are standing at one corner of a large rectangular field and decide to race to the opposite corner. Since Maya had a bike and Tyler did not, they thought it would be a fair race if Maya rolled along the sidewalk that surrounds the field, while Tyler ran shorter distance directly across the field. The field is 100 meters long, so 100 meters long. Let's label that 100, and 80 meters wide. Tyler can run at around 5 meters per second. Maya can run her bike at 7.5 meters per second. Okay, keep that in mind. So Tyler is 5, Maya is 7.5. Before making any calculations, what do you think who will win, and by how much, and what is your thinking? So go ahead and just kind of answer that question. Think about it. Okay. I'm looking at it going, okay, Maya's faster, but she also has to go at a longer distance. So I think she's going to go ahead and beat Tyler, but probably not by a much. Okay? And then, so let's look at number 2. Number 2 says, okay, who will actually win? We're going to go ahead and work through that. So go ahead and pause, answer that question, and then come back to me. So let's look at just Maya. Maya went all the way around. She did 100 plus 80. And so she went 180 meters. And let's kind of figure out like her rate of change, kind of like how fast she is going. So we're going to take the 100 meters, and we're going to, some meters, and we're going to divide it by how fast she rides, which is 7.5 meters per second, right? So we're going to say 180 divided by 7.5. What do we get? We're going to get 24, okay? Now let's talk about Tyler. Tyler actually he went ahead and he cut across, right? This part is Tyler, but we have to figure out what that distance is. So we're going to say 100 squared plus 80 squared is the c squared because it's a rectangle, right? C is always across from the 90 degrees. So we're going to have 100 squared, right? That is 10,000. Let's have 80 squared, 64,000 or 6,400. C squared, add it together. We're going to have 16,400 equals our C and then our squared. So remember, to get C by himself, we need to go ahead and square root it. So square root of that amount is going to be around 128 point, let's do 1 is our C. So that's the distance. we're going to go ahead and take that number. We're going to divide it by how fast he goes, which is 5. So 128.1 divided by 5, and we get 25.6. So it's actually Tyler that is faster because it's 25.6 and Maya was 24. All right, let's turn to page 89 through 90. And we have 2 rectangular prisms. So we have like cube and that kind of stuff. And which figure do you think has the longest diagonal? Note that the figures are not drawn to scale. So notice the measurements that are actually on there. And then calculate the lengths of both diagonals. Okay, so go ahead and pause, answer that question, and then come back to me. All right, so I think the prism L, which is this one over here, I think that one has the longest diagonal since it has a larger volume than prism K, but it kind of has the same dimensions. But let's go ahead and let's figure that out. So what we're going to do is what I call is the Pythagorean theorem. So notice I have it written up at the top. It is our height squared plus our length squared plus our width squared, and then square root all of that after it's been added together. So let's try it with prism K. So we're going to have our diagonal. So diagonal equals 6 squared plus 4 squared plus 5 squared. 6 squared is 36. 4 squared is 16. 5 squared is 25. Let's add that all together. And that is going to be the square root of 77 if you add it all together. And then let's go ahead and figure out the decimal on that. So it's going to be about, if we run it to the nearest tenth, so that's 1 decimal place, it will be 8.8 is our diagonal for K. Let's go ahead and try it with L. So diagonal, and it's going to be 5 squared plus 5 squared plus 5 squared. So it would be 25 plus 25 plus 25. Add them all together, which is 75. So this one is square root of 75, which actually is going to be shorter than the other one. Let's make the decimal of it. This one, our diagonal, is going to be 8.7. So just a tiny, tiny, tiny bit smaller, but actually prism K is bigger. So this is the way of figuring out the diagonal within a prism, like a cube. It's called a rectangular prism. And remember, it's our length squared plus height squared plus our width squared. Doesn't matter which order. Add them all together and then square root it. We'll be able to go ahead and figure that diagonal. If you need to go ahead and pause, rewind this, go ahead and go through it again. Make sure you write down that formula. You will need it for today's practice problems. So what situations can you think of involving right triangles? I know that sometimes when we go ahead and deliver a package, we can stick some like a rod inside a package diagonally. There's many different ways that we can actually go ahead and use this as far as figuring out that diagonal. I know that we also use it sometimes when we're working in construction. We have to put a pipe in an area, so we're going to have to know how long that's going to go ahead and be. Go ahead and turn back to page 136 and 137. Read the ICANN statements for lesson 9. I can explain why it is true that if a side length of a right triangle satisfies the equation a squared plus b squared equals c squared, and then it must be right. And then if I know the side lengths of a triangle, I can determine if it is a right triangle or not. And then also lesson 10, solving equations with using the Pythagorean theorem itself. So today it's only lesson 10 practice problems. That's all we have to do. Technically, we've already gone over lesson 9. That was through the Nearpod. Lesson 10, the more of the focus is that 3D Pythagorean theorem. I hope you have a great day. Thanks. Bye.